Good afternoon, and welcome to our 25-26 Winter Weather Outlook webinar. My name is Andrea Berg, and I am your host for today's session. Before we begin, I just wanted to go over a few housekeeping notes. We are recording this presentation, and in the next few days, we will be sending out a link to the recording along with an infographic that summarizes the winter outlook forecast to everyone who has registered for this webinar. So if you want to listen to it again or share it with a colleague, you will have those links probably by Tuesday of next week at the latest. If you're experiencing any technical difficulties, please use the chat feature and message me, the host, and I will help troubleshoot those. We will be taking questions at the end of the presentation. So at any time during the presentation, please feel free to enter your questions in the chat or the Q&A feature. With that, I'm going to turn the presentation over to Stephen Davenport, who will take you through the long-range forecast.
Thank you, Andrea, and a very good day to you all. I'm Stephen Davenport, Weather Risk Communicator with the Long Range team at DTN. And this is what we'll be looking at today. First up, a review of what last winter brought us, a run through the techniques that go into our seasonal forecast. That includes analogs and computer model outlooks. And look at the current and future state of the polar vortex. Then we'll mix in the pure global seasonal dynamic models that project from the current atmospheric and ocean observations, and that'll lead us all to DTN's official outlook through the winter. And we'll finish up with a quick look at the rest of the world. Firstly, a reminder of what last winter brought us. So highlights from last year. After El Nino the winter previously, we saw a La Nina develop through midwinter with cooling of the equatorial Pacific peaking in January, although it was a rather weak La Nina. As we'll see, that's something that we'll have partially in common with this winter. We also had above average sea surface temperatures across the larger part of the North Atlantic, meaning a positive phase of the Atlantic multi-decadal oscillation, or AMO, and that'll be the same this year as well, but a positive phase of the QBO, the quasi-biennial oscillation, that's going to be negative this year, and more on that later. So these are reanalysis charts for December 2024, showing a strong northward jet stream, which helped to promote above average temperatures across Northern and Eastern Europe during December, but closer to seasonal over Central and Western Europe. Low pressure systems tended to follow the course of the jet stream, and that brought above average precipitation from Scotland to Scandinavia. Our cut-off low pressure systems also brought some unsettled and occasionally stormy conditions in the central and eastern Mediterranean. A split in the jet came in January, with one branch shooting into southwest Europe and through central areas, or the second arm far north, and that meant an active and mild pattern across much of Europe, but also brought chances of high pressure blocking at times towards Iceland and Greenland, and that caused some colder outbreaks to push down across northwest and western Europe, where temperatures were very variable, averaging near or slightly below normal. This is partly induced by a disruption to the polar vortex with a sudden stratospheric warming event. In February, we saw a northward shifted jet again with milder than average conditions towards the Arctic and near seasonal values overall for the month as a whole across most of Europe. High pressure was often centered over northeast Europe and Scandinavia, and that led to far eastern and southeastern areas having some colder outbreaks around its eastern flank. Most areas, except the central Mediterranean, were rather dry. The active jet stream shifted a little southwards in March with a parade of low pressure systems and plentiful precipitation into Scandinavia, especially Norway, so a good hydro for there. It was a mild month for most of Europe, particularly in the east and southeast. Southwest was cooler and rather active and wet, with that southerly jet reinvigorating. So these are the average surface pressure patterns from December. Pretty clearly shows the variability at the surface. This December had a recurring Atlantic ridge pattern with high pressure near or west of the UK, while in the purple and blue colours, that's showing the low pressure track across Europe during January, with high pressure overall near Iceland. Rather persistent high pressure developed over northeast Europe and Scandinavia in February before high pressure weakened for March. And note the persistent low pressure that brought the wet weather across the Iberian Peninsula. Now, we could see any or all of these sorts of patterns at times this coming winter. These were the temperature outcomes, as we've already seen with those colder January periods across northwest Europe due to the high latitude, high pressure near Iceland and negative NAO pattern for a while. And the precipitation patterns showing above normal, as noted, from Scotland to Scandinavia in December, then the wettest conditions shifting southwards in January. February then had a lot of dry or seasonal conditions, but wet and thundery outbreaks around the central Med. Then in March, parts of Spain, Portugal, central southern Europe were wet, while much of north central and northwest Europe became drier than usual. Now, due to the milder conditions, there was a rather a paucity of low-level snow across much of Europe, despite the elevated precipitation places. But areas from far northern Scotland to southern Scandinavia and into northeast and eastern Europe were just cold and wet enough for average to above average amounts, and the Alps were closer to seasonal. Renewables now, and due to the north shifted jet and low pressure track, there was reduced wind output across a large part of Europe through the winter, or seasonal levels at best. But so winds were above average around the central Med and central southern Europe, chiefly northern Italy, due to periodic cut-off flows that brought that stormier weather. Solar output was rather depressed across West and North Europe, but better than normal for some eastern and southeastern regions. Closer look at the UK's average temperature and precipitation for December through February. It doesn't highlight much due to the month-to-month variability, but overall the winter averaged near to a little above normal, while there are no outstandingly wet areas. Breaking that down month by month, we can see above average temperatures right across the UK during December. Rainfall amounts higher in the north than the south, and that's even with Storm Dara, which you might remember brought disruptive rain and winds around the 7th, with the Met Office issuing red warnings for parts of West and South Wales and Southwest England. In January, after heavy rain and some local flooding on New Year's Day, there was a colder shot of air around the 5th, with rain and snow across England and Wales. Snow warnings issued, some roads and airport runways were closed, but milder air soon pushed in before another cold shot followed to start the second week of the month, with some very low overnight temperatures in Scotland, while parts of southwest England had a shot of snow. Later in January, there was further disruption from a couple of storms, Aoin and Armenia, and southerly track of the low pressure systems is during January is pretty much indicated by the south-north split in the precipitation anomalies on the right there. And that path allowed colder air to come southwards on the northern side of those lows. February started cold, rather dry, with high pressure to the northeast. That forced chilly easterly winds towards the UK for a while. But then milder and more unsettled conditions took over for the second half of the month, with high pressure shifting and allowing milder west to southwesterly flows across. And overall, that split resulted in temperatures averaging near or above normal for the month, with precipitation mostly near or below normal. This shows the ups and downs of the temperatures. Very little cold showed up in December, but there was an extended colder than average period during the first half of January, followed by relatively small variations around normal, and then February had modestly cold spell, but much milder weather in the second half of the month. Well, that's behind us, so let's get into what we think lies ahead. What do we have to look forward to? Well, like last winter, we're seeing a weak La Nina developing. It's on its way already, but it's earlier than last year and should peak through late autumn and early winter before trending towards neutral conditions in the equatorial Pacific later in winter and into the spring. A more significant difference perhaps is negative or easterly phase of the QBO rather than the positive or westerly QBO we had last winter, and we'll get into that in a little while. Not least because of that, the stratospheric polar vortex is weaker than last year and a little weaker than average, and that might turn out to have an impact on our winter conditions. On the other hand, we've still got the same sort of pattern of sea surface temperature anomalies in the North Pacific and continuing warmth in the North Atlantic with sea surface temperatures widely above average. One final thing is particularly warm seas compared to average in the Arctic with low sea ice extent. A reminder now of the last couple of months. August was warm or hot across most of Europe with notable heat and dryness across parts of eastern, southeastern and southwestern areas with drought conditions exacerbated. The exception was an area from Scandinavia into northeast Europe, which was wetter in parts and cooler with some troughing across there. And as well a bullseye of high pressure centered on southeast France and northwest Italy due to a couple of sluggish low pressure systems bringing some heavy rain and thundery activity. Elsewhere, though, there's a lot of drier than normal weather. In September, the pattern shifted with the jet stream and low pressure tracks moving southwards, and that led to copious rain across much of northwest, west central and northern Europe, including the Alps. But the month as a whole was warmer than normal, although cooler flows periodically came into northwest Europe with near to below average temperatures for the UK and parts of France. Despite the September rain, here's the drought situation in late September with a few areas of drought scattered across the continent, but more widespread and locally severe in southeastern Europe. The Iberian Peninsula could see problems next spring if, as we're expecting, the winter stays rather dry. Now let's start digging into the seasonal forecast. Let's start with the main influence on the winter season. ENSO, the oscillation between El Nino and La Nina, is typically one of the largest contributors globally. About 40% is typical, but sometimes more, sometimes less. And less this year because we're expecting a weak event, and Europe is that much further from the source. Nevertheless, predicting the state of ENSO has pretty good skill. The polar vortex contribution has fair skill, and that accounts for about 30%, especially if conditions are ripe. It's not something that we can pinpoint far in advance, but there's some skill at least in identifying the conditions in which polar vortex disruptions become more likely. Actually predicting the disruptions themselves and their impacts is more for a couple of weeks ahead. So it's more of a sub-seasonal influence. Other subseasonal factors like snow cover and the MJO have pretty low skill, especially this far in advance, of course, and a low contribution. And then there are the trends of what's happened in the last few years or 5 or 10 year periods, which have pretty good skill. So on to teleconnections and our main seasonal drivers. Well, first off, what exactly are teleconnections? Well, these are patterns driven by large-scale ocean atmospheric interactions, and we have some of the main ones marked here. Atmospheric connections over vast distances mean that phenomena in one part of the world can have an effect in a distant other part. And the most well-known of these is, of course, ENSO cycle, La Nina and El Nino. And the La Nina shows up pretty clearly in this seasonal forecast of sea surface temperatures from the ECMWF model for December through February. Let me just clarify a few of the abbreviations. AMO, the Atlantic Multi-Decadal Oscillation, which is positive when the North Atlantic sea surface temperatures are warm overall. The PDOs, the Pacific Decadal Oscillation, a pattern of temperature anomalies in the North Pacific. Now that's in the negative phase as it is at the moment when it's warmer than average, but with a cooler strip of waters towards the coast of North America. And so the El Nino Southern Oscillation, that's the alternating cool and warm sea surface temperature patterns in the equatorial Pacific, La Nina, El Nino cycle. And as we've seen, we're heading into the cooler La Nina phase. The IOD is the Indian Ocean dipole, and that acts in a similar fashion to ENSO, with positive and negative phases depending on which side of the Indian Ocean is warmer and cooler. And finally, there's the QBO, that's the quasi-biennial oscillation, and that measures the change in lower stratospheric winds between westerly or positive phase and the easterly or negative phase, and it cycles through about 28 months on average. This map, by the way, is still the ECMWF sea surface temperature forecast. And because ocean temperatures change slowly, they can often guide us to longer range prospects. There's a quick schematic of the two ENSO phases showing opposite circulations associated with La Nina top left and El Nino bottom right. So you can clearly see how these could affect large-scale circulation patterns elsewhere around the globe. Given that it may play a role this winter, or possibly already is, it's worth looking at the QBO. Unlike the strongly positive or westerly QBO state last winter, we've got an increasingly negative or easterly phase this year. Now, when the QBO is in its positive phase, then it tends to encourage a strong polar vortex, but it can have a weakening effect when it's in the easterly phase. And this year's QBO is quite strongly negative or easterly, so that's favorable for that sort of occurrence. La Nina can be as well, but not so much this winter. It's a weak event and a Central Pacific based episode rather than the Eastern Pacific. The easterly QBO then can force large-scale planetary waves to extend further north and knock the polar vortex out of kilter and disrupt the jet stream, with sudden stratospheric warming events possible, which would allow a weaker, wavier jet stream and chances of colder air coming southwards. Now, if we cast our eyes back to that cool water in the equatorial Pacific, the La Nina that we're headed for early this winter shows up. It's already developing with an ongoing cooling trend through the next couple of months. So we should see weak La Nina conditions in November and December, and perhaps into January, before weakening, late winter and into spring, with a neutral state developing. In the Atlantic, there's the persistent positive phase of the AMO, resulting from widely above normal temperatures, aside from the cooler blobs south of Greenland. And while we're here, note that strong anomalous warmth in the Arctic, including the Barents and Kara seas, where there's a low ice extent. In the Indian Ocean, there's the IOD, the Indian Ocean dipole. Negative at the moment, expected to trend towards neutral through the winter, much the same way that the ENSO cycle is going. Then in the Northern Pacific, the negative phase of the Pacific Decadal Oscillation, the PDO, and it's rather unusual to have such North Pacific warmth alongside La Nina. But if we look at years in the past that most closely match these and other drivers, we get an idea of what might occur through the coming winter. Matches are often hard to find, especially with such strong warmth in the Atlantic and what's going on in the Pacific and the equatorial Pacific. But there's certainly value in finding the closest. Other influences are Arctic sea ice cover, which I briefly touched on, especially the Barents and Kara seas, Eurasian snow cover, and solar activity, which we'll come to. Low sea ice and a bigger buildup of early season Eurasian snow cover can both be correlated with risks of a weaker stratospheric polar vortex. So they'll need to be watched this winter. A weaker polar vortex can allow high pressure build near Greenland and Iceland, a negative state of the Atlantic Oscillation, or NAO, and that can be a predictor of cold outbreaks at the subseasonal range. So, favouring a warmer or at least milder than average winter for much of Europe are the warm AMO and the negative PDO phase. But if the North Atlantic finds itself more strongly warmer than normal, there could be risks of northern blocking and a negative NAO pattern emerging at times, perhaps more frequently, bringing colder risks to the forecast. But greater cold risks come via the low Arctic sea ice extent and the increased Siberian snow, which could help lead to more high latitude blocking. We're expecting a weak and relatively short-lived La Nina. That might limit the impact downstream in Europe, although some correlations can be found. An east-based La Nina with the coldest seas near the South American coast in region 1.2 is more favorable for blocking patterns to emerge, implying chances of high pressure blocks near Greenland or Scandinavia and Ural regions. But as you'll have noticed from the sea surface temperature chart, anomaly charts, we're looking at a more centrally based La Nina across the Nino 3.4 region, more in the central Pacific, and that tends to shift northern hemispheric blocking features farther west. So here are predictions for the ENSO forecast from various modeling centers across the world, and the average represented by the thick dark red line. And then that average shows a weak La Nina developing for November and December, barely below the minus 0.5 degrees Celsius threshold. Looks like peaking at around minus 0.7 at its coldest, somewhere around there. The largest consensus of models is right around that point, but a few of them show a stronger La Nina and a couple of others outliers go the other way. So most likely we'll have weak La Nina peaking in late autumn, early winter, and that'll gradually weaken through the first and second quarters of 2025 towards neutral, and eventually might even head towards El Nino development next summer or autumn, but that's another story for another day. Another way of looking at predictions is with this probability graph, which shows La Nina is most probable through to January before neutral conditions become increasingly likely late winter and into the spring. The Bureau of Meteorology in Australia tells the same story regarding La Nina development and weakening, with sea surface temperatures dropping to about minus 0.8 below average in November and December before slowly warming. So confidence in the La Nina is relatively high. The bigger impact of La Nina is across North America, so it's worth a quick look. Is the typical average winter flow of the jet stream during La Nina events, and you can see that it dips southwards across the central northern US, allowing chances of occasional frigid outbreaks to pour southwards. But for other parts of the globe, here's a look at the various typical patterns of El Nino and La Nina. The one we're most interested in is bottom center, which suggests an active jet stream and storm track from eastern Canada to the northern UK and southern Scandinavia, not far off what forecast models are expecting, aside from the risks of blocking that we've already mentioned. There's a difference in pressure patterns around the northern hemisphere, depending on whether or not La Nina is early or late in the season. We're expecting an early peak this year, of course, and an early peak shows chances of high pressure building in December over or around Greenland and Iceland, which I've circled here. And that's a negative NAO pattern that can lead to cold outbreaks into Europe. Note on the right that late peak, with a late peak, there's lower pressure in the same place, and then extended Azores high, and also high pressure shifting near Alaska. A positive NAO would be in place with less of a cold risk. The AMO next, and that's the measure of the Atlantic sea surface temperatures. It remains positive, although less strongly so than last winter when there was near record warmth in the North Atlantic basin. Nevertheless, it's still mostly above to well above average. Now, La Nina has some correlation with positive and winter temperatures across Europe, while positive AMO has a stronger correlation with positive temperatures in Northwest Europe, and that's the graph on the right. PDO has a negative correlation, so the negative PDO we're seeing indicates positive wintertime temperature anomalies possible for much of Europe, especially across Northern Europe. The QBO has a weaker linkage, but positive QBO correlates with a mild winter and vice versa, hence the colder risks in our forecast for this winter. We're all pretty familiar these days with the stratospheric polar vortex. And here's a quick comparison of strong and weaker polar vortices. Strong polar vortex, strong polar vortex is circular. It tends to bottle up cold towards the pole, with a strong and relatively regular jet stream at around 60 degrees north. But a weaker polar vortex can break into southward moving parts and induce a weaker and wavier jet stream. An extreme cold can follow where the polar vortex and the jet stream break and dip southwards. Of course, it's tough to know exactly where and when that might be, with this being more of a sub-seasonal range prediction, as I've already mentioned, but we can get an idea of when conditions are right for an increased risk. And that this year looks like mostly being in early winter. The polar vortex is weakening on average already, as you can see from this ECMW graph. This is a spread of ensembles, with the average shown by the thick blue line. And this forecast has it staying below the climate mean into December, and that means it might be susceptible to disruption via a sudden stratospheric warming event in early to midwinter. If the polar vortex avoids this disturbance like that early in the winter, then it might still be precondition for a breakdown later winter, or perhaps more likely early spring. So early cold might make late cold less likely, and vice versa. We mentioned the negative QBO and weak La Nina impact. You can see it here. When the two are combined, we tend to have a weaker polar vortex. The chart on the right shows a few analog years, and it's got below average winds around the polar vortex, indicated by those purple colors. Further model guidance agrees with the idea of a weaker polar vortex, at least through early winter and into the very start of 2026. There's the ECMWF again on the left, and the forecast on the right is from JMA in Japan. But note the wide range of ensembles, though, so uncertainty is high on exactly where it will go as we head into midwinter and later in the winter. Back to analogues of the polar vortex broken down into months. You can see there's an indication of a weaker polar vortex in December, supporting the idea of possible disruptions and cold outbreaks early in winter, while January, see the yellow bands, show a strengthening vortex. We see from this the possibilities of a weak polar vortex recurring by early spring in these analogues, but as I mentioned, if we have an early breakdown or displacement, then it's statistically less likely to also occur late in winter, or indeed in early spring. The type of disruption or alignment of displacement of the polar vortex can guide just where around the northern hemisphere the cold will break out. So if we do get these disturbances, then Arctic cold could easily be directed towards North America or Asia and miss Europe entirely. So that's something that becomes predictable only a couple of weeks ahead. This bar graph is just a handy visual for showing the relationship between sudden stratospheric warming events and the state of ENSO. And we can see that sudden stratospheric warming is more likely during La Nina years, and most likely during January and February, but we might just buck the trend with the possibility of seeing one in December. If not, then maybe into January. Arctic sea ice, or rather the lack thereof, can also be a pertinent factor when it comes to the polar vortex. With warmer seas and low ice extent, especially in the Barents and Kara seas, there's less to inhibit northward extending ridges and transport of warmth across the Arctic and towards the pole. And that disturbs the polar vortex, or it leads to sudden stratospheric warming events. At the moment, Arctic sea ice extent is near record low levels and expected to stay low as we go into winter. Siberian snow cover is something else to consider. If there's a quick build-up of snow in October across Siberia or Eurasia in general, as there has been this year, It can lead to colder air masses and high pressure blocking. This can also disrupt the polar vortex as strong high pressure sends more energy up into the stratosphere and knocks at the polar vortex. Increased snowfall is expected in that area into November, so it could be primed. And we can see some correlation between Northern Hemisphere snow cover and cold for Europe. Also, we can look at the high snowfall year and see that they correlate with the weak polar vortex with easterly winds, while the 5 lowest years had a stronger polar vortex surrounded by westerly winds. So it's a comparison between left and right. So that's another indicator of possible polar vortex disturbances this winter, particularly early winter. Just a quick glance at the Indian Ocean dipole here. Currently, seas are slightly cooler in the Western Indian Ocean than the East, so the IOD index is negative, which the image on the right shows. And note the opposite circulation on the left when the IOD is positive. So just like the El Nino La Nina cycle, it can have far-reaching effect on global circulation. So it's another ingredient in our analog mix. Forecasts are for the IOD to stay negative through to December, but it should rather rapidly weaken and end up neutral by January. And this is the forecast from the Australian Bureau of Meteorology. We've mentioned the NAO previously, the North Atlantic Oscillation. And these maps show the correlation of air temperatures on the left, while on the right is the correlation of the AO, the Arctic Oscillation, the related phenomenon. So we can see the significance of identifying positive and negative phases of the NAO and the AO whenever we can. That's generally something that's also more identifiable at the sub-seasonal level. Something we shouldn't overlook, although not necessarily highly impactful, is the solar cycle, which can be a factor in determining the probability of the NAO state via its connection to the stratospheric polar vortex. From this chart, you can see sunspot numbers are high despite a recent drop, and we haven't fallen far from the maximum of the solar cycle. Contradictory to the negative QBO years when the solar cycle is near maximum, tend to result in a stronger polar vortex at least until late winter when disruptions can still be possible. So this maybe gives some faint support to the idea that if an early winter polar vortex disruption doesn't occur, then it might be possible late winter or early spring instead. So let's put these analogs together and see what they come up with. So the analogs are based on a weak central Pacific-based and early La Nina, a very warm North Atlantic, the strongly positive AMO, the negative PDO, and the negative QBO. The IOD is secondarily factored in. The top 4 of these years are the best analogs for the positive AMO, negative QBO, along with a weak La Nina. This is where our analogs take the La Nina prediction, very similar to the model forecast average we saw earlier, and close to the same value at its peak, maybe a 1/10 of a degree colder, something like that, while peaks around the same time and warms just a bit more slowly towards neutral by early spring of 2026. If you recall the ECMWF model forecast of sea surface temperatures, then you'll see that our analogs come up with a pretty good match for SSTs, showing the negative PDO pattern, the positive AMO with the anomalous warmth across the Atlantic, and the cool waters of the central-based La Nina in the equatorial Pacific. Using the analog list, here's what they indicate for the average position of the jet stream through winter from December to February, and you can see it's reasonably far north across Northern Europe. But of course, this doesn't preclude the chances of more blocked and colder period over shorter periods, or whenever the jet becomes weaker and more variable. And what do our analogs show across Europe for temperature and precipitation? Well, during December, widely above average temperatures, most anomalously warm in Central and Far Eastern Europe. Low pressure tracks indicated near the southern UK, northern France, north central Europe, with above average precipitation for those areas. Colder air at northern latitudes like northern Scandinavia, though, could have occasional risks of breaking further south on the northern backsides of low pressure systems, and especially if we do see those disruptions to the polar vortex. So overall, analogs indicating warm, but always that risk of a colder outbreak should the polar vortex disrupt. January is similar, just with more cold getting into Scandinavia, but above average or at least seasonal temperatures for most of Europe. Again, the strongest positive temperature anomalies look like from North Central to Eastern Europe. But those areas are going to tend to be the wettest as well, with occasional troughing from Scandinavia to Eastern Europe, while Southwest Europe trends drier according to the analogues under developing high pressure, and far Southeastern Europe shows up cooler. February analogues have a colder trend, especially across Central and Eastern Europe as the patterns shift, with potential high pressure ridge patterns near Western Europe, which analogues suggest will be drier than usual, but still have low pressure track from Ireland across parts of Scandinavia. More cold risks show up in March, with analogues indicating possible ridging from Iceland to southern Scandinavia and Central and Eastern Europe, and a possible negative NAO. Drier than average conditions suggested for much of Europe as a result. The low pressure systems cut off below that high could make Spain and Portugal wetter. I had a glimpse at April as well, which also shows a colder outlook. So maybe analogues want to show us the possibilities of early spring cold risks, but again, that's going to be partly predicated on the strength of the polar vortex and whether or not it disrupts early in the season. December to February overall then shows what is an unsurprising pattern, a lot of warm anomalies, especially for North Central and Eastern Europe. Wettest conditions across North Central Europe and Far Eastern Europe, but some above average precipitation in Southeastern Europe as well. Southwestern Europe would be rather dry for the season as a whole, despite the late winter possible wetness. That's not all, though. Of course, next input is the global weather models, the predictions from several computer models of large-scale weather patterns across the season and around the globe. But first, we'll just dig into the next few weeks. The pressure pattern forecast by ECMWF looks like this: low pressure dominating central, northern, and north and western Europe through the rest of this week, top left there, with very unsettled and windy conditions, including some severe storm threats. We've got Storm Benjamin moving through at the moment, of course. Then in week 2, troughing should shift eastwards, and that's next week as high pressure moves into Western Europe. And note also the high pressure near Iceland, but that dissipates in weeks 3 and 4 with a positive NAO pattern emerging, low pressure tracking across Northern Europe with higher pressure to the south. Here's a way of looking at possible Atlantic European regimes via the ECMWF model. These are the regime probabilities. And here you can see the green bar showing a negative NAO patterns, then increases in probability of Atlantic ridge patterns. That's the purple bars. Both of those indicative of cooler flows. Then in blue, there's that positive NAO regime becoming more probable, which should result in a rise in temperature. The result looks like this, with next week, week 2, having those chillier northwesterly flows across northwest and western Europe as an Atlantic ridge regime unfolds, but warmer flows should still affect Far Eastern and Northeastern Europe. Above average winds quite widely, except in Scandinavia and parts of Southwest Europe, while we see wet conditions prevailing across Southeast Europe. Although much of Northern and Western Europe should trend drier after the very wet and windy conditions through the rest of this week. Weeks 3 and 4 should see a change to milder weather as Atlantic sourced air spreads across Europe in a more positive NAO regime with generally west to southwest flows across Northern Europe. Parts of Northwest, West and Central Europe will become wetter though in week 3 as Atlantic frontal systems swing through with winds above normal. Then far northwestern and northern Europe could be wetter in week 4. A quick look at the tropical Atlantic to see if there are any developments possible and any risks of recurving across the Atlantic. Models suggesting there is a chance still. Tropical convection patterns kind of back that up. We already have Tropical Storm Melissa in the Caribbean, which will potentially become a major hurricane south of Haiti and Jamaica, causing problems down that way. This track's really uncertain, but it could possibly start to head north with a risk of recurving northeast. There's something to look out for, as any recurving storms can disrupt weather patterns downstream across the Atlantic. But I suppose the good news is that conditions become much more unfavorable for developments by mid-November. And now the seasonal models for the next few months, we'll be looking at model guidance from the European ECMWF model and the American CFS model. First, the ECMWF month-by-month outlook, that shows consistent above average temperatures across most of Europe. Of course, it's unlikely to look exactly like this, with models not picking out timings and areas of any cold pockets, as we've already discussed, even if they're temporary. Still, it's showing mild overall, except in southwest Europe during December. December looks wettest in central, southern and southeastern Europe in this model, and southern Norway. Much of central and western Europe have rather dry indication in January, but February and March turn wetter. Rather low winds shown by ECMWF in December and January. That's due to high pressure being modelled in the vicinity of northwest Europe. In December, then centred closer to North Europe overall in January. It's showing more of a positive NAO regime for February and March, with increased winds across northern Europe, but more of a build of the Azores high into continental Europe during March. CFS model shows little difference in the temperature anomaly pattern, but it's even a little milder than ECMWF, depicting above average temperatures each month right across Europe. Conditions look wettest across northern parts of Europe and rather dry for the south, especially during December and January, with signals more washed out in February and March. That's consistent with a positive NAO pattern throughout, which is less likely than the more variable ECMWF forecast, but both at the moment indicating overall milder than average conditions. There's more wind evidence in the CFS model anomalies across northern Europe as a result of its expected patterns. Similar in February, although strongest winds are shown to push further north in March as European high pressure expands, according to this model. One more model, in fact, a multi-system model, the C3S multi-system, which is based on the models of the main European forecasting centres, and that depicts high pressure over the Atlantic and far western Europe for the far eastern Europe for the November to January period, along with above average temperatures everywhere. So still that mild theme. But for the December to March period, things become very blurred with no overriding pressure patterns showing up, indicative of a lot of disagreement across the models and a widespread of ensemble solutions. Nevertheless, the temperature outlook still shows temperatures solidly above average. Now let's wrap all that information and put a bow on it with the official DTN forecast for the upcoming winter. Bear in mind that, consistent with the uncertainties I've mentioned, changes to the forecast are always possible moving ahead, depending on changes in the shorter range climate drivers. So the forecast is compiled by taking the climatology and narrowing that down to trends over the past decade, then relating this to the statistical analogues from the teleconnections and some of the seasonal computer models to create our final forecast solution. Given what we've already seen, it's not going to come much of a surprise that our forecast is for above average temperatures across much of Europe for December to January and even February, but there's some important proviso that I keep mentioning. Rather low confidence because of the chances of the weak stratospheric polar vortex getting disrupted and letting colder air break southwards. That could be somewhere else in the Northern Hemisphere, but possibly into Europe for a period of 1 to 2 weeks. But again, even if so, exactly where in Europe is problematical until we get closer to this putative event. Some colder risks appear in February for Eastern Europe and in March across West and Southwest Europe. And more widespread cold could be possible early spring if the polar vortex especially fails to break down in early winter. Just as unsurprisingly, it means the winter as a whole is forecast to have above average temperatures rather widely, with strong anomalies in Far Eastern Europe. Probability forecast suggests reasonably high confidence, especially for Southwest Europe. But again, we need to bear in mind the occasional colder risks. We run several alternate scenarios, and the warmer one naturally is even warmer than the forecast, while the cooler scenario depicts below average temperatures quite widely. The warmer alternate scenario has slightly higher probability on the understanding that any cold outbreaks will be relatively short-lived. But we must keep in mind the factors leading to potential colder risks early winter or possibly early spring. For late winter and into the spring, although this exact pattern in the colder scenario is unlikely to evolve, it does give indications of some colder chances by April. Again, this might be predicated by not having a polar vortex disruption and cold outbreaks early in winter. Looking at the forecast pressure patterns, our forecast has a low pressure track from the UK to southern Scandinavia in December, more high pressure over Western Europe in January with a trough across the northeast, before in February high pressure becomes centered more over north central Europe. This is similar to the analogues for winter and not too much different to the ECMWF model. Precipitation now, and the outlook looks like this, with wetter than normal winter across wetter than normal conditions in December across north central and parts of west and northwest Europe, with a period of snow possible if the polar vortex disruption sends cold in that direction. That's an above average rain and snow indication for Eastern Europe as well, but some dryness in the southwest, which lasts into January. The dry area becomes broader across Western Europe in February, but Southwest Europe turns wetter than average in March. And if that occurs, there could be some persistently heavy rain and flood risks due to slow-moving low-pressure systems trapped south of a high-pressure area to the north. Central, Eastern, and Northwest Europe become drier in this scenario, with high pressure building. For the winter as a whole, December through February is the precipitation pattern, wetter than normal across northern and central Europe, drier than average in the southwest before the potentially wetter March sets in. For renewables, western and central, north central Europe are most likely to have above average winds in December, along with parts of northeast Europe and southern Scandinavia. But January looks calmer in Western Europe, and Italy looks below average in both December and January. Stronger winds become more probable across northwest, central, and parts of Western Europe, also western and northern regions of Scandinavia. Solar is less significant, harder to pin down at long range, but given the expected pattern, then solar could be best in Southwest Europe early in winter and North Central Europe later in spring, but always with the proviso that if high pressure dominates, then fog and low cloud can always be an issue. Winter as a whole then looks like this: good wind protection across the northern half of Europe, no better than average in the south, while the solar outlook is just completely washed out. Way back, we had a quick look at expected snowfall and concluded that for much of Europe, despite the above average precipitation across northern and central Europe, snow should be below average because of the expected mild conditions. However, Scandinavia should be cold enough for average to above average snow amounts. The Alps, meanwhile, could be near seasonal, but there's rather low confidence there. And this neat infographic sums up our official DTM forecast. I'll just leave that up for short minute while I catch a quick breath. Here's a look at the global picture, and what stands out is a lot of warm anomalies across the world for the northern hemispheric winter and southern hemispheric summer, and notably a hot summer potentially in store for much of Australia and parts of South America, but note also a very wet patch in parts of northern and eastern South America. There's a notable cold pocket over northeast China and eastern Siberia as well. Across North America, a typical La Nina pattern, as I mentioned earlier, with coldest risks mainly across central northern areas, the Midwest and the bulk of Canada, especially the prairies. Again, bear in mind any polar vortex disturbance could send frigid air to almost any region around the northern hemisphere, particularly early and perhaps late winter. It's worth a quick closer look at the USA. So here's a summary and another infographic. Stormy and wet early in the season in the northwest with some heavy mountain snow. The north central US will have heightened cold threats and above average snowfall, while the southwest is warm overall. Initially, the south and central US are warm as well, but January and February could have increasing cold risks. The Great Lakes, the Ohio and Tennessee valleys, and the lower Mississippi Valley will have volatile temperature swings and risks of some heavy lake effect snow at times around the Great Lakes. The Northeast also could have large temperature swings, but less rain and snow than usual, with the storms tracking further inland than normal. Southeast should be warmer than average, especially late winter, but brief colder shots are possible. And when they occur, they could be sharper than usual, bring a occasional slight frost and freeze risk to Florida. So here are the key takeaways from the forecast. Confidence is rather low because of the wild card of the polar vortex and difficulty in pinpointing exactly when and where any cold outbreaks may occur. To wrap up, we'll have a quick run through some industry impacts based on the forecast. Above average temperatures should mean below normal energy demand, but with high variability. If we get those abrupt colder spells, we'll get sudden higher demand possible. That says especially early spring here, but more likely early winter than possible again, early spring. Above average winds for the northern half of Europe, but seasonal below the southern areas, chance of occasional disruptive low pressure systems with wind and rainfall impacts, and generally below average lowland snow and ice, but except during those colder spells. Near to above average in parts of northern Europe, especially Scandinavia. For transportation, variable jet stream from north shifted with a weaker than average jets for southern Europe, meaning impacts on fuel and flight planning. Above average temperatures overall, but the risk of cold outbreaks could mean periods of actionable nights for road, rail, and air. Less snow in most areas than normal, but sudden falls are possible during those colder periods. And with that, that's all I have for you. And if we have time, we'll invite any questions. Andrea, have you seen any questions?
Yeah, I have a few questions that have come in, but as I am giving these questions to Stephen, if you have any, please use the chat feature on the right-hand side of your screen to enter those questions now. So Stephen, the first one I see here is you mentioned the strong QBO phase. Is there any chance that this will become westerly rather than staying negative so that the polar vortex strengthens?
Well, in a nutshell, that's pretty unlikely. The QBO, thankfully, is one of the atmospheric drivers that's reasonably predictable, or at least its westerly and easterly phases are, if not the absolute strength in either direction. So we can have reasonably high confidence that it won't suddenly reverse because it cycles through an average of about 28 months. and a quick switch would buck every trend that we've ever known. It should become less strong by late winter, but stay in the easterly or negative phase. So the polar vortex should still remain susceptible to weakening if we've not had a significant disruption in December or January, that is.
All right. Another question around polar vortex. If there is a disturbance to the polar vortex in early winter, does that make a second disturbance at the end of winter or early spring less likely?
Yeah, I've almost covered that in the last question. Yeah, it would be less likely. The reason being, after an early disruption, the vortex would naturally reform and recover to some extent, meaning it's less likely to suffer another disturbance again later on in the winter or in an early spring. Statistically, it also has a low probability, so yeah, that would be less likely.
Those are all the questions that I see that came to me. Stephen, do you see any that came directly
I
to you in the chat?
don't see any questions, no.
All right. Well, with that, Stephen, I want to thank you so much for this very informative webinar on what to expect this winter. We will be having our next webinar, which will be the spring and summer outlook in April. So please look for that and look for the recording of this webinar and the handy infographic that you can use to reference the long range forecast for this season in your inbox in the next few days. So with that, I wish everyone a great afternoon and you can all disconnect. Thank you.